In Lesson 8 today, students learned about variability in data distributions. And I'm going to really quickly go through these. They had a problem at the beginning of the class where Robert had to decide where he wanted to live, New York City or San Francisco. And he really was considering the temperature of the two cities. He wanted to live in a warm climate. So to help Robert in his decision, the students first were asked to find the mean temperature for both of the cities. And when we calculate the mean, you add up all of the numbers to get a sum, and then you divide by the number of numbers that you add together. So I just added 12 months together for a sum of 756. Now I'm going to divide it by 12, and the average temperature in New York City is 63 degrees. So then we said, okay, let's find the mean temperature of San Francisco. And again, added up all of their temperatures for the months. And we're going to divide that by 12. Okay? So then the students and I talked, and we're like, okay, well, the average temperatures are very close together. It really wouldn't help Robert make a decision. So that's where variability comes in. We wanted to look and see how far the temperatures varied between the two cities. And that's another thing to help us with data distributions. So New York City had an average or mean temperature of 63, where San Francisco balanced or had an average temperature of 64. So as you can see by looking at the dot plots here, okay, the variability in New York City's temperatures is much greater than the variability in San Francisco. San Francisco's temperatures have a range of 13, highest minus the lowest. And New York City, 85 is the highest, 39 is the lowest. So that is a 46 degree temperature range, okay? So then the students were able to say, oh yeah, definitely. Okay, we need to move to San Francisco, Robert. Okay? And that was again seen down here. We talked about bus times. Okay, and the students were asked to make a dot plot of bus time. So here's the dot plot, okay, and from these dot plots, the students were asked to find the average time that it takes people to get to school in the morning and in the afternoon. So I have 1 at 11, 1 at 12, 2 at 14, 1 at 16, and 1 at 17. That's a total of 1, 2, 3, 4, 5, 6 people riding the bus. So the average or the mean travel time in the morning is going to be 14 minutes. Okay, and then we are going to calculate the average time it takes to get home in the afternoon. So I add up all of the dots, and there's 6 people that they surveyed here, and the mean was also 14. So the lesson went on to ask, is a mean of 14 a better representation for the morning or the afternoon bus ride home? And hopefully the students learned today that the afternoon bus ride home, a mean of 14 is a lot better for the morning, because the range or the variability, there's a 6-minute range of times in the morning bus ride, but the afternoon bus ride varies a lot more. It has a range of 13 minutes from maximum to minimum number. So this is really a lesson in when should you use the mean. I think for this afternoon one, I would tend to use the median here, and I would take 13 plus 18 and divide them by 2, and I would get 15.5. I think the median here would be a better representation of this data distribution. And we'll go on to talk more about this as our statistics lesson continues. If you're watching this with Educanon, hopefully you'll answer the next couple of questions that appear. Thank you for watching my video on Lesson 8 on variability.